you need to find first fx. What's f of x? Fx xyz going to be equal to? 2x. What's fy of xyz going to be equal to? What? Negative 1 over what? So just to make it even more fun, let's just make it negative z to the negative 2. What's f of z going to be? What's that going to be? What is it? It's going to be 2y z to the, like that. I'm just writing it in one line. Am I okay? Did I do okay? So what are they asking you to find at each of these points for part A? The gradient, right? So one of them is going to be 0. Sorry, I'm plugging in 0, right? So when we're at the first point, it's going to be 0. What's next? Come on, kids, help me out here. And then I plug in x, y, and z, so it's going to be 0, I think, right? Yeah. Is that a unit vector?
No. Oh, yeah.
It isn't a unit vector? Were we guaranteed to get a unit vector? No. Is the gradient vector always going to be a unit vector? No. Does it happen to be in this case? Mm-hmm. So this one is u1. Yay, exciting. So then the second one, what do we plug in? 1, 1, 1. What is it? 2, negative 1, and what? 2.
Yeah.
What do we need to divide by?
Square root of 9.
Square root of 8?
9. No, wait.
So what do we divide by? 3. So that is u2.
Oh, it's like
Have normal vectors, and we have a point. What's the equation for a plane? A times x minus x naught plus b times y minus y naught plus c times what?
z minus z.
Z minus z naught equals 0. ABC is a normal vector. Well, did we just find the normal vectors we want? So what's the first plane going to be? Well, it's ABC. It's going to be 0, negative 1, 0, negative 1, and what? 0.
Yeah.
And then it's so it's going to be x minus 0, y minus 0, and z minus 1. So does that simplify rather nicely? Yeah, what does it turn into? Negative y equals? So there's the first tangent plane. Yay, exciting. Doesn't matter what x and z are. It's just negative y. Wherever you are, it's just negative y. So then the other equation is going to be what? Do we care about this 3? Do we need that 3? Does the magnitude of the normal vector matter when you're constructing the equation for a tangent plane, for any plane? No, it doesn't. So we can just use 2 times what? X minus 1 minus y times 1 plus 2. Thank you. It is 2. Thank you. 2 times z minus 1 equals 0. You could stop there or you could keep going, but is this a plane?
Yes.
Yeah, here's a plane and here's a plane. Nice. Exciting. Okay. Find all points on S where the normal vector is parallel to the xy plane. What does this mean? Parallel to xy plane. What does that mean? And I'll stop using the highlighter because it's annoying and obnoxious. I'm sorry. What does that mean? Parallel to the xy plane, mathematically. In terms of the vector itself, what's the only thing that needs to be true? So if this right here is the xy plane right here, the vector, it has to be parallel to the what axis? What does it mean? Parallel to the xy plane means what has to be true about the vector? There's 3 components to any vector, correct? In 3 space? You're overthinking. No, overthinking it. If you're parallel to the xy plane, what's the one thing the vector can't do? It can't intersect the xy plane, right? Or it has to be on it, right? So what's the only thing, if you had to write a vector, 1, 2, 3, is that parallel to the xy plane? Why? Vectors don't have a starting and end point, but if you drew that anywhere in space, what would that vector eventually do? How do you know it would hit the xy plane?
Because it doesn't have 0, 0 as the axis.
No, you're getting closer. It has to do with one of those 3 numbers, number 1, number 2, or number 3. Number 3, because the z component of that vector is 3, What does that mean the vector is doing? It's going up, right? It has to be what? Horizontal. Any vector that is only traveling horizontal is parallel to the xy, right? So what's the only number we need to be 0? That has to be 0. Do we care what the other numbers are? No. Any vector, length, whatever, right? It could be 1 billion miles long or 1 centimeter long. As long as the z component is what? 0, the vector will be parallel to the xy plane. Are you with me so far? But the third number, the z component, has to be what?
0.
0. Okay. So we're trying to find all the points on the curve. What does it say? It tells us f is equal to 0. And what does it tell us f of x, y, z is? X squared minus y over z squared. So what surface are we looking at? If f is 0, and that's the equation, what surface are we looking at? 0 equals x squared minus y divided by z squared. That's what we're looking at so far, right? We're looking for all of the points on S where a normal vector. Which vector is normal at any given point? The gradient vector. Number to be, we need this to be equal to what? 0. We need it to be equal to 0. So 2y over z cubed has to be what? 0. What's the only way for that to happen? And what else has to be true? No, hold on. No, just based on that equation, we're getting there. Z can't be 0, right? Because what happens if z is 0?
It's just undefined.
Undefined, right, exactly. So what do we know here? Therefore, y must be 0 and z what? Can't be 0. But the point has to be on this, correct? So what do we do with y equals 0? Plug it in. So what do we get? 0 equals x squared. So x has to be 0. So what are the points where there are 3 things have to be true? Y is 0, z is 0, and x has to equal 0. What is that set of points? What is that called?
Origin.
Not the origin, because z can't be 0. It's the z-axis except the origin. And then you're done. Correct. There it is. But the key realization, not the key realization, but what makes this question doable is the following. The gradient vector is what? Perpendicular, normal to the curve. That could be a surface, it could be a 2-dimensional curve, but it's always perpendicular. Okay, what's the best thing you should do right now? What should I draw? A little chart thing. So z is in terms of what and what? X and y. And then u and x and y are both in terms of u and, so they're both going to both of them, correct? So what is it asking you to do on this? It's asking you to find partial z. I'll do one of these. Partial, which one do you want to do, v or u? V, okay? So what do? You trace out the paths from z to v. So there's one and there's the other, right? So what is this going to be equal to? It's going to be equal to partial z, partial y, times partial y, partial v, plus partial z, partial x, partial, not, oh, these aren't partials anymore, right? Oh, no, they are partials. They are partial because there's multiple choice. Yeah, sorry. Partial v.
Which ones are D's and which ones are partials?
They're all partials because how many choices do you have in each x, y, and z? From z there's 2 and from y and x there's 2, right? So they all have to be partials. They all have to be partial. So what do you just have to do? You have to do dz dx, dz dy, dz dx, right? dz dx and dz dy, and you have to do partial y, I meant to say partial y, partial v, partial x, partial v. And then you just multiply all that stuff together. Go to the board and do that now. It's so